Math 3 Lesson Summary Video. Any way you spin it. This lesson is a develop understanding task, which is meant to introduce you to a concept, but not necessarily finalize rules or strategies. The purpose of this lesson is to develop skills for visualizing solids of revolution generated by rotating two-dimensional objects about an axis. Draw and describe the solid of revolution formed by rotating this triangle about the x-axis. So, as we're looking at this, first thing I want to identify is what is the x-axis. So the x-axis is this line right here. And if you remember our transformations, rotating is spinning something around something else. So if we're going to spin around this axis, this is what we're revolving around, this triangle is going to go in a circle. Now the big thing is, how do I get a shape out of that? One of the things I realize is if it's going to spin, it is going to end up reflecting because it's going to come all the way around this. Reflection is very similar to a part of that rotation. It's going to get to the other side. So if I think about this reflecting over that line, at some point in the spin, the triangle should end up down on this side of that line of reflection. So that's as far away as it's going to get. And as it's revolving, I need to remember that it is making a circle. So if this triangle goes around that axis, it would appear that the shape that I'm going to end up with is a cone. That's how I would describe it, as a cone. Now find the volume of the solid formed. So I do need to remember what is my volume for a cone. And when I do a cone or pyramid, we said that our volume is 1/3 the area of the base times the vertical height. So looking at our cone that we got here, this circle, what revolves is this side of the triangle revolves around this axis. And so this right here is going to become my radius. Now I can actually look on this picture and see that it is 2. It has a radius of 2. So the area of a circle, if you recall, is pi r squared. So that's going to be pi 2 squared. Our formula says to take 1/3. Now I need the vertical height. This is where the circle is for our cone, and it goes all the way up to this point. So that looks like it is 1, 2, 3, 4 long. So we have a vertical height of 4. And so we get 1/3 pi 2 squared, which is 4. And 4 times 4 is 16. And then that's going to give us 16/3 pi for our, and so we don't really have centimeters or meters, so we're just units for our volume for this particular cone. What about the following two-dimensional figure? Draw and describe the solid of revolution formed by rotating this figure about the x-axis. So we're going back around the x-axis again. So locating my x-axis would be important, right? From our last one of the things that we said we wanted to do first was to find the reflection of our shape. If we can find the reflection of our shape over whatever axis it is that we're wanting to rotate around, that kind of gives us the other side. It really gives us a cross section. If we think back to our last lesson, it gives us a cross section of our three-dimensional shape. So if we start by finding the reflection, that helps us to make that rotation. So if this is the axis that I want to rotate around, I need to reflect everything on it. So this looks like it is 1, 2, 3, 4, 5 spaces away. 1, 2, 3, 4, 5. Then it looks like it goes up to about right here. and that appears to be 6 away. So I'm going to come down here just short of 6, and then it starts coming down again, and then down, 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 down. It looks like the bottom of this little curve is about 2 and a little more than a half. 2 and a little more than a half right here. So we're going to make a nice curve. And then we come back up to 1, 2, 3, 4. 1, 2, 3, 4. And so then I can end right here. So this gives us a nice reflection, and so we get that cross section of what our shape is going to look like. After we find our reflections, what we wanted to do is figure out where is it spinning so that we can put in our circles. Where is it spinning? So if I'm spinning around this, this is going to be a radius, and so I end up with a circle at this end. This also is revolving around, and so it looks like I have a circle down here. Now some people with three-dimensional shapes like to make, when the lines go behind, if you know that it's not something you would actually see, often they'll make it dotted or dashed and say, oh, we don't actually see that line because it's going behind. We get a very vase-like shape for this particular rotation of a solid. Why is it that we would even want to have these kinds of rotations? What's the use of having these type of rotations? And it really boils down to when we're doing solids that don't really exist, it's kind of out of context. But solids of revolution are used to create mathematical models of real solids by describing the solid in terms of two-dimensional shapes that generate it. And so if I wanted to find the volume of this vase, I don't have a formula for that particular shape. And so one of the things that we will often do is we will try to make that shape a two-dimensional shape that when rotated gives us this shape. And we have some strategies that we're going to be talking about over the next couple of days for helping us to then figure out what the volume of that shape is. If I wanted to try and find a two-dimensional shape that would get rotated, the first thing I want to figure out is where is a good line of symmetry? What could it be rotated around? I think if I had a line of symmetry going through here, this isn't going to spin because this doesn't match. It's not symmetrical over this line. But if I were to have a line going this way, it is symmetrical. It's the same on this side as it is on this side. So that would imply that it could rotate around and it would line up. So I want to use this axis of symmetry to be the axis that it's going to get rotated around. So then I start looking at how big. So I have a little piece right here, and then it kind of goes up, and then it comes down into the neck part of it, and then it appears to go back up again and kind of have a rim around it. And then if we were to reflect that to the other side, you would see a very similar shape as it's spinning. And remember, we get the circle at the top and the circle at the bottom, and that's going to very much give us our vase-like shape.